Hey there, this is Vance again, and right now I'm going to teach you the mechanics behind the Roman compression bridge. So every single stone bridge or any sort of stone arch is all going to have the same feature, and that's this ring of stones that goes along the arch, and each of the stones or bricks or blocks or whatever they happen to be runs parallel to the diameter of an imaginary circle, and I'm going to illustrate that in a moment. Now, we do that because stone's building quality, or the best quality that it has for construction, is that it's very, very good against compressive force. It can handle up to 28,000 pounds per square inch of compression. The opposite of that would be like cables to make a suspension bridge. They're terrible with compressive force. You can easily take a cable and smash it together, but it's really, really hard to pull it apart, so it's great with tensile strength. So in order to use the compression strength of this stone, we're going to have to create this arch that will make all of the different stones lock in together and compress against each other. So I'm going to show you how we do that. So right here I've simulated a little stream, and I didn't cut this thing in half. Our normal, your insert for your bridge will only be half of this, because it'll be lying flat on the ground. But imagine this right here is our channel of our stream running in between these two big blocks right here. Okay, the stream bed is going to be even with this corner right here, and the water's flowing through. Now you've already poured your concrete footings on either side, and now you're ready to start building your blocks up across your bridge. So you take your form that you've made, I've included instructions in another segment, and you place it in between your two footings here like this. Then you're going to start to build your blocks up and around the top of this thing. So you're going to want to use, if you can purchase, like some pavers from Lowe's come naturally angled, and those would work great for this if you want to do a dry stone bridge or not use any mortar. But if you're using natural stone like I did, it's really hard to get that perfect angle in it, so I used a mortar. Right here I'm going to simulate the mortar using these shims here. So you would take your block, you'd put down some mortar, you'd smash your block into that, and then you'd lay down another thing of mortar, which is this shim here, and you'd put your next block, or your next couple of blocks, depending on how wide you need it to be. And now you're just going to keep doing that all the way around this arch. A little bit of mortar, blocks, mortar, blocks, all the way around. And you're going to want to stagger these gaps right here, or else you're going to end up with several narrow bridges. So I wouldn't do it like that. I would probably actually grab a longer block that would span both of these for this and put it in like that. So I keep coming up and around, a little bit of mortar, another block, keep it coming. That one didn't need it for the particular angle that it was at. Shim, block, and now we come to our capstones. These ones we want to be perfectly vertical, and we just shim in whatever we need remaining out here like this. So we use a little bit wider shims for mortar, like this, something like that. Okay, and we'll shim in there like that. So now we have this bridge of these. Now this right here is the origin point of our circle, okay, or it's the center of our circle. And if you draw a line straight from this point out to the edge of the bridge, it should run straight through one of these stones. And what that does is, as I press from the top, all these stones are going to press against each other, and they're going to lock into these foundations. And that's why it's so important to have really, really good footings poured, because as it presses against these footings are going to want to migrate apart like this. And so if you can put your footings inside of a stream bank that comes up like this, then your footings are going to press against that huge stream bank. It's going to have a ton of weight to press, and so it's not going to slide apart. So after I've got all of this put together, then I can remove my form. In this case I'm going to have to do it pretty carefully. And the compression of the weight of all these is going to hold them together. And I have myself a compression arch bridge.